Okay, so in this video I'll be talking you through the Leaving Cert Higher Level Maths ExamCraft 2016 Paper 2 Question 5 and it's a trigonometry question. A bit of a difficult question, but not that bad. Like you should be able to understand most of it anyways, and then it gets down to an awful lot of algebra and multiplying out brackets, and you just need to be careful. So watch the video once, I'd say, and then go and try the question again. So in a triangle XYZ, XYZ is equal to 90 degrees and YZ, the angle XYZ is equal to 90 degrees, and the length YZ is P, and that's in the diagram. Show that WY is here, is equal to P tan 45 minus alpha, and that's that angle there. So you can see we're going to be dealing with just this triangle here to begin with. We know that tan of any angle is opposite over the adjacent, and in this scenario the opposite is opposite the angle that we're given, which is 45 minus alpha. So it's going to be WY over the adjacent, which is going to be P here because it's beside the angle that we're given. And we simply have to multiply across by P to get WY on its own. That WY is going to be useful in a minute now. Okay, so the second part of the question says, hence or otherwise show that XW is equal to 2P tan 2 alpha. Okay, so it's a double angle here. Double meaning the angle is multiplied by 2. So we're probably going to end up using our log tables, the double angle formula here in the log tables, somewhere along the way to get tan 2 alpha. Okay, so just being aware, somewhere we're probably going to end up using that. We want to get XW on its own. So you'd either consider using this triangle. Now, looking at this triangle, it's a non-right angle triangle. And we're kind of dealing with tan here, so we want actually to deal with the right angle triangle. So because we're dealing with tan, we would consider this triangle here. Could we find what this angle is? Well, it's going to be 45 minus alpha plus 2 alpha, which works out to be tan of 45 plus alpha. So what's the tan of 45 plus alpha is opposite, which is xy, over adjacent, which is yz, which is the length p. So we end up getting tan 45 plus alpha is equal to xy over p. Multiply both sides by p, and we don't want to get xy on its own. We want to get xw, but this length xy is xw plus wy. So you could replace that xy with the xw, which is what I want to find, plus wy. And this is where the hence comes in, because I know this can be brought in there. Okay, because I know that's what wy is. Okay, fantastic. Now I've got two things that look relatively similar. Tan 45 plus alpha, tan 45 minus alpha. So again, back to our log tables. A tan of an angle plus an angle, a tan of an angle minus an angle. So we end up using that in the log tables as well. This rule right here, where you can spot A is 45, B is alpha, A is 45, B is alpha. Just one's plus and one's minus. So we're filling all of that in. Be very careful then. We know that, or you should know, the tan of 45 is one of the nicer angles to deal with, because it's 1. Type it into your calculator, you'll see tan of 45 is 1. Which simplifies matters really, really well. Okay, what do I not like right now? I don't like fractions. So get rid of the fractions. Multiply everything by 1 minus 2 alpha. Multiply this by 1 minus 2 alpha, you get rid of the fraction. Multiply this by 1 minus 2 alpha, just put it beside it in a bracket, 1 minus 2 alpha. And multiply this by 1 minus 2 alpha, you can just, it'll be multiplying into the top line, because in the second we're also going to multiply by 1 plus tan alpha. I can't remember if I just said 1 minus 2 alpha. It should have been 1 minus tan alpha if I was saying 2 alpha. Multiply everything by 1 minus tan alpha. Multiply this by 1 minus tan alpha, 1 minus tan alpha, and 1 minus tan alpha. I might be just going a little bit quick and getting ahead of myself. Then we're going to multiply everything by 1 plus tan alpha. Multiply this by 1 plus tan alpha. You'd get rid of the fraction. Multiply this by 1 plus tan alpha. It just gets put beside it. And multiply this by 1 plus tan alpha. It's going to, well, there's only going to be the top line left, so it'll be multiplied by the top line to get this. So taking our time, again, we have only got the top line left, and we're multiplying by 1 plus tan alpha from the fraction on the right hand side. This, the xw gets multiplied by the 1 minus tan alpha and the 1 plus the tan alpha, because there's no fraction to cancel with. And the top line here is just going to be left with the 1 minus tan alpha, because we multiplied by 1 plus tan alpha to get rid of the fraction, and we're still getting that 1 minus tan alpha from multiplying everything by 1 minus tan alpha. Multiply everything out really slowly, be really careful. 1 by 1 is 1, tan alpha, 1 by tan alpha is tan alpha, 1 by tan alpha is tan alpha, so I'm getting 2 tan alpha by tan alpha is tan squared alpha. Here, you could know that this is the difference of two squares, or you can just multiply it out the long way yourself. 1 by 1 is 1, 1 by tan alpha is tan alpha, minus tan alpha by 1 is minus tan alpha, hence these two in the middle are going to cancel. Minus by plus is minus, tan by tan is tan squared, and similar over here. 1 by 1 is 1, 1 by minus tan alpha is minus tan alpha by 1 is minus tan alpha, that's where we're getting our minus 2 tan alpha. Minus by minus is plus, tan by tan is tan squared. Continue to multiply it out, multiply in the p's, and what you'll then find is when we try and bring all the terms with p's to the left hand side, that's going to cancel. And what else will cancel? That will cancel. And when you're going to add 2p tan alpha to both sides, you're going to get 4p tan alpha. Now divide by this bracket to get xw on its own. Remember, i's in the prize, what we're trying to find. And this is where the double angle comes in. We can factorize out the 2p. Fine, factorize out 2p. Because, remember in the question it said get xw is equal to 2p tan 2 alpha. So I kind of want a 2p out the front. That's why I'm factorizing out the 2p. Well, then there must be something in tan 2 alpha in the log table somewhere. A tan 2 alpha in the log table somewhere? Yeah, there absolutely is. It's right here. Tan 2 alpha is equal to 2 tan a minus 1 tan squared a. And that's what we have here. So we can use our simple bit of substitution. QED, job done. Next part of the question is a proof. I'm not going to do that. I'm going to link to the description a video of the proof. So if you're looking for a video of the formal proof of the theorem, go have a look in the description. I've already done it. Really worth learning off the theorems though, because if they do come up, it's kind of guaranteed easy 10 marks at least that you should be very, very happy. So spend some time looking at the theorems. Hopefully you found the video helpful anyways.